So that's the original function I'm interested in, minus the polynomial at x. Hopefully these are quite close, yes? This polynomial is the thing I'm comparing it to. Yeah? Okay. I hope this is small. Are these going to be equal? No, not necessarily. So let me subtract off m, for that number m you said was clearly existed, times x minus a to the n. Okay, now, why in the world would I do this? Well, it's maybe not clear yet. It'll become clear soon, but you can't stop me from defining this function. Okay? And what am I hoping? I mean, where is this headed? Well, it would be nice if I could show that g of x were 0 somewhere, yes? And maybe m was this coefficient, right? That sure would be nice. Okay, check this out. So look at what happens when I take the nth derivative of g. What happens when I take the nth derivative? Well, would you agree this is the nth derivative of f? Minus, help, 0. I'm going to ignore it. Thank you. And the nth derivative here, m. This is so cool. What's the nth derivative? N factorial, and that's it. So the nth derivative of x is just f to the n of x minus m times n factorial. And what I claim then is it's enough to show, what I'm trying to do is, will certainly be enough to show that g sub n of some point c is 0 for some c. For some c in between a and b. Why would that be enough for what I'm interested in? If I could show that this creature were 0 somewhere, that would make fn of c equal to m times n factorial. So that would establish that m is in fact the nth derivative at some point c over n factorial. Okay. And what would that do? Well, let's see. I'm kind of, yeah. Well, so that would be nice because then the thing that I'm interested in, this expression, would actually be what? Well, I'm hoping this thing is actually equal and this thing's going to be 0. Okay. So let's just see what happens here. So we can check a few things about g. So the nice thing here is, tell me, this function g, what is its value at a? What is this function's value at a? A minus a is 0. F of a minus Pn minus 1 at a. Why is it 0? They have the same value, right, at a. If I plug in a here, these things vanish. So g of a, in fact, is going to be 0, since f at a equals p sub n minus 1 at a. You can check that. Right? Okay. Okay. What if I take the derivative of g prime, and plug in a? Well, let's see. This is the first derivative at a is the first derivative of f at a minus m times 1 factorial at a, g prime at a. What do you get? What is g prime at a? 0. Why? Good. Okay. So yeah, right. So right, this is the nth derivative at right. So if I take the derivative here, I get g prime at x minus f prime at x minus the first derivative at x minus m and the n. Right. Right. Sorry. That was just the nth term, but I want the first term. Right. So this vanishes, and f prime and p prime have the same value. That's basically what we see. So in fact, if I look at the second derivative, I'll also get 0. Why? Because f prime and p prime have the same value at a, and this one's true because f double prime at a is the same as p double prime at a, etc. So in fact, what I've done is I've constructed a function that's very, very flat at a, right? I mean, up through the n minus 1th derivative. Okay? So this is an important fact. G is very, very flat at a. Okay. Well, what else do you notice? Well, check this out. What if I look at g of b? What happens when I plug in x equals b here? B, B, B. Why is it 0? Yes, Smiley shows that this is 0 by Cyclops Smiley. Right? That's the definition of M made this true. Okay, so here's what I have. I have a, here's the point A, here's the point B, and I know that at A, G prime is 0, that G is 0, right? And I know at B, G is 0, yes? So if I have a function that's 0 at both ends, then it either has a max or a min in between. Therefore, there's a point in between whose what? Whose first derivative is 0. So I don't know where that point is. Maybe it's here. There's a place, G prime of C, which is 0. Yes? But what do you know about G prime at A? It's also 0. Right? Okay. Good. So I have a place where G prime is 0 and at A and at C. Therefore, good. There's a place in between where the second derivative is 0, which is the derivative of G prime, which I'm assuming exists because we are assuming this has enough derivatives to keep taking derivatives. Oh, somewhere between these two, yeah? Maybe here. Let's call this C1. There's a place where C2 is 0. Okay, help? Yeah, so what I'm saying is there exists a C1. There exists a C2. Continue. What do I know about G prime at A? It's also 0. Therefore, there exists another place in between C3 where G prime of C3 is 0, etc. Keep going. How far can I keep going? Good. So by the time I get down to, let's see, the last step here, what will I